8 in 5, lesson 7, comparing linear functions and graphs. This is a review lesson of sorts. We know how to do this kind of stuff. We know how to, I will explain what this lesson's about, and let's just get right over to it. Let's just do that right now on our drawing pad. So this lesson is all about building blocks and prior lessons. You know how to do these things. Specifically, every problem in this lesson, including your problem set, is about solving a system of linear equations. Solving a system of linear equations. And so there's two key pieces here, actually. This whole idea of linear equations means that everything can be written as y equals mx plus b and graphed as straight line. Okay, and now the fact that it's a system means that there are going to be two equations. Well, systems can have three or more, but system just simply means at least two. So two equations that usually, and in this case, in lesson 7, always have one common solution. And they can be solved graphically or algebraically. And if you recall, graphically, it means if we want to solve graphically and algebraically, because these are equivalent, and we've learned this in 8 and 4 and repeated it over and over, the graphs and algebraic equations are the same, can be the same thing, are the same thing. So graphically, you're asking the question, where do the two lines meet? And algebraically, you're saying, if I use substitution or elimination, where can I get the common XY ordered pair that solves both equations at the same time? That's why it's a simultaneous system of equations. Okay, so these are both skills, this graphically and algebraically solving of equations. These are both skills we learned in Unit 8 and 4. And what I'm going to do is we're just going to do 4 different examples using T-charts, graphs, verbal models, and algebraic equations to ask you some questions and make sure that you've really mastered this concept of solving simultaneous equations along with the critical thinking skills necessary to put things together. Okay, well, let's look at what these 4 problems that I have created are all similar to the ones that you're going to see on your homework. So this is, everything here is homework help. So let's look at these examples that are very similar to problems you're going to be doing on your homework. So let's see, who is saving faster? Andy or Bella? Okay, and in this case, what do we have? We have Andy has a graph. We have a graph of his savings, and we have of Bella's savings, we have a T-chart. Now, the interesting thing about these two different examples is, one, we don't have kind of the same days graph. Here we know kind of what Andy did on day 0, 1, and 2, but we kind of don't know what he's done out here on 5 through, on 5 through 10, or even 3 through 10 and beyond. For Bella, we know, 10 through 15, but, from 0 to 10, we kind of, or 0 to 9, we don't know, and then 16 and beyond, we don't know. But none of that matters. Why? Because we're just going to think about the savings rates. We're thinking about the rates. We know that both of these are linear because I've told you that. We're not looking at who started with more because, right, what did Andy start with? Andy started with 0. We don't really know what Bella started with. We're just looking for rates, and rates are the same thing as slopes, which are the same thing as delta y over delta x, which is the same thing as y2 minus y1 over x2 minus x1. So I've given you a lot of hints here. So I want you to pause and try this example that is basically just a refresher on what you already knew how to do probably a month ago. Okay, so the strategy is going to be to use algebra. I want you to put these both in algebraic equations just to find the slope. Okay, now I assume you're back. So let's look at Andy. Andy is probably a pretty easy, pretty easy guy to figure out here, because we know that our y-intercept is 0. B is 0 if we're going to write the equation, right? Starting point is 0. And now if we want to find the slope, we find our delta y over our delta x. We could also just, draw our picture here. Our rise over our run. Here, let's do all this in red. Okay, and so the rise over the run, the rise is $8, and the run is 2 days. So 8 over 2, that's 4. So it's 4, and then what are our units? Our units are our y over our x, so dollars per day. $4 per day. And that's our m. So our equation here is y equals 4x, which we don't really need to know, but just to be really complete, that is our algebraic function, and this is our rate. And this is really what we're asking about, right? We're really asking about who is saving faster. Now let's look at Bella. Let's see how Bella's doing with her savings. Well, we just need to find a delta, delta y over delta x. And we can take any 2 points. So let's just take these first 2 points. Our delta y is 48 minus 42 over 12 minus 10. So that's 6 over 2, or 3. And remember, our first column is x and our second is y. So our units are y over x, and so that's $3 per day. And that's our slope. So you can look and see who's saving faster. And we know, if you're just looking at the question here, we know that Andy is saving faster, because he saves $4 per day, and Bella's saving $3 per day. Now we can write the equation for Bella, and we can see, but we haven't, so we don't really know the B yet. We can see how much Bella started with, and let's just go ahead and do that. Nothing in the question asks you this. In fact, I specifically say I don't want to know who started with more, but let's just see where Bella started. And we can do that. With y equals mx plus b, we can take our 3 and put it in for m. We can take our point. Let's take this point, 42 equals 3 times 10 plus b, right? I took my x is my 10 and my y is my 42. I could have used either of the other 2 points, but I'm going to use this first one. And we'll say 42 equals 30 plus b. So b is 12. Right? Subtract 30 from both sides. And that's our starting point. And our equation then is y equals 3x plus 12. Well, that's Bella's equation. So if someone had asked, you would have said, well, Bella started with $12. But no one asked you that. So when you said that Andy was saving faster, you got this problem correct. Let's move on. I'm just going to put this homework help title at the top of all of these 4 problems, because I forgot to do that. And let's head back to problem number 2. So this is problem number 2. So now we're going to ask the question, and all of these questions are the same thing. When I talk about savings rates or how fast cars are going or how fast water is filling or, you know, which floor costs more, you know, all of these things are going to be the same question. After you take it out of the world of verbal models, these things are all algebraic, and all the algebra is exactly the same. It's going to be comparing two different equations and answering questions about them. Okay, so here we have a Chevy and a Ford that are driving down the road. Now, the Ford starts in San Francisco and the Chevy starts in Gilroy. Now, I'm just going to tell you that Gilroy is 60 miles down the road. So, right, so the Ford's driving from San Francisco to Gilroy and on beyond. The Chevy's just starting at Gilroy and going beyond. So we're going to model that in this graph and say the Chevy starts at 60 miles. And here's an equation, or here's a graph that shows you how fast and how far the Chevy is going, you know, in miles. And this is how many hours it's gone. So after 0 hours, it's gone 60 miles because it's starting in Gilroy. And then it's going at a certain rate down the road. The Ford, though, starts in San Francisco way behind. So it's, you know, its B is 0. It's starting, you know, you could say y equals 60x plus 0. And that's an equation, y equals 60x. And this is, x is the hours driven, and y is the total miles traveled. And so what I want you to do is I want to figure out when they meet and how far down the road do they meet. How far from San Francisco, where down here do they meet? Okay, so now I want you to pause and try. And we'll solve it in green. Okay, now I assume you've thought about it, tried it, written out two equations, and then solved them, because that's going to tell us where they meet. Okay, here we have a graph, and so I know here that my B equals 60. That's my starting point. So now I just got to find my slope, and my slope is going to be determined by my rise over my run. Let's take these 2 points. And my rise here then is 40, and my run here is 1. So that's in miles per hour. My y over my x is my units. My units equals y over x. My y units over my x units. And so that's miles per hour. That's my units. And then my rate is 40 over 1. Or 40. So my m is 40. So if my m is 40, my b is 60, my equation is y equals 40x plus 60. So these are, and this is my distance in miles. And that's my y, and then my x is my hours traveled. So now I can solve my two equations. So let's do that. Let's just cordon off a section here, and I'll say, well, y equals 60x. That's my Ford. And then I have y equals 40x plus 60. Well, I'm going to use substitution here. I'm not going to use elimination. I'm going to say, well, if y is equal to 60 and y is equal to 40x plus 60, then I can just set these two guys equal to each other. And this will be hopefully easy to figure out. 60x equals 40x plus 60. So let's subtract 40x from both sides. And we get 20x equals 60. Divide by 20. And we get x equals 3. And what is x? X is hours driven. So after 3 hours, they should meet. And let's make sure that that's true. Let's test it. Well, how far has the Chevy gone in 3 hours with its 60-mile head start? So let's check. Let's just check it. Let's just use blue again. So let's see, the Chevy has gone 40 times 3 plus 60. So that's 120 plus 60, and so that's 180. And then the Ford has gone 60x, so 60 times 3, so that's 180. So they've each gone 180 miles down the road from they're 180 miles down the road from San Francisco. And so that's how far down the road they need. 180 miles from San Francisco. And they meet after 3 hours. Happy cat, happy cat, happy cat. You know, lots of happy cats, because this is a lot of work, a lot of meticulous work. But kudos to you for sticking with it. Let's move on to problem number 3. Why are we on Stone Giant? We got to go back to our happy cat. There we go. Let's put a happy cat up there just for some good karma. Uh-oh. Get happy cat out of the way. Now, here we go. We are talking about Josie and about Carl. Now, who saves more in 20 days? Well, let's see. Josie starts with $20, and so we have this chart here where after 0 days, the beginning, she has $20. And then after 4 days, she has 30. After 6 days, she has 35. And we know it's a linear equation because I've told you that. So we need to figure out how to model this. Then Carl, we have a graph. We need to figure out how to model Carl's savings. So I'm going to let you pause and try. Okay, 1, you want to write the equations. And then just figure out at 20 days who has more. All right, I assume you're back. Let's look at Josie. Josie, we start with 20, so we know our B is equal to 20. Now let's find our M. Our M is delta Y over delta X. So let's see. These are our X's and these are our Y's. So 30 minus 20 over 4 minus 0. So that's 10 over 4 equals 5 over 2 equals 2.5. So that's here's our B, and that's our M. Hopefully these are getting a lot more straightforward for you now. So Y equals 2.5 X plus 20. Right? And Y is what? Y is dollars. This is our Y, and this is our X. Our X is days, and our Y is dollars. And over here, Carl, let's see. Well, Carl, we know he starts at 0. Let's go to orange. So our B is what? Orange. Orange. Our B is equal to 0. Our B equals 0. And what is our rate? What is our, let's see. So let's see if we can figure this out. Our rise over our run. Our rise is 15. And our run is 1, 2, 3, 4, 5. So our M is equal to our rise over run. So that's 15 over 5. That equals 3. So then our equation is Y equals 3X plus 0. So I'm not going to write the plus 0. Now the question is not when do they have the same amount. If the question was when do they have the same amount, I would just solve a set of equations. But it says who saves more in 20 days. So I can figure out how much Carl saves in 20 days, because remember, X is days and Y is dollars. So we'll just figure this out. In 20 days, days is 20, Carl will have $60. Carl has $60 after 20 days. So let's see, Josie after 20 days, let's plug it in. 2.5 times 20 plus 20. Well, 2.5 times 20 is equal to 50 plus 20. That's 70. So Josie has $70 after 20 days. So the answer is Josie has more. If you wanted to figure out when they have the exact same amount, you would just set the equations equal to each other. And so you would say, well, y equals 2.5x plus 20, and then y equals 3x. You would use substitution, I think, because that's easiest. And so you'd set those two equal. And you'd say, well, 2.5x plus 20 equals 3x. Subtract 2.5x from both sides. And you get 20 equals 0.5x. You divide by 0.5 and you get 40 equals x. So the answer would be 40 days. After 40 days, they'd have the same amount. So let's lay down some happy cats. Happy cat for solving this, happy cat for solving this, happy cat for writing this equation, happy cat for writing this equation, happy cat for going the extra mile if you did and figured out how many days before they actually saved the same amount. And then let's just spin a happy cat just because we're almost done. All right, final question. We have two companies that install floors at your house. AAA, and they charge a flat fee of $2,000 for coming out and doing the job, and then they charge $10 per square foot. So if you have a house with 10 square feet that you need to install, they would charge you 10 times 10, $100 plus the $2,000 to come out. Billy Bob's, on the other hand, they charge $500 flat fee for coming out, a lot less to start, but they charge $15 per square foot. So they charge more money per square foot. So the question is who gives the better, let's see, when do they charge the same amount? For what size floor do they charge the same amount? And then who gives a better deal for floors that are smaller than that amount? And who gives the better deal for floors that are larger than that amount? All right. So what you're going to do is you're going to write two equations, solve them, and where they meet, where they match, or where the solution is for that set of simultaneous equations, that's going to be the size floor that is the same price. Okay, so let's go ahead and do that. So I want you to pause and try. And again, this is like one of the homework problems. Hint, hint. Okay. And let's just think, this flat fee is kind of like a starting point. That's what it costs for 0 square feet, right? I'll make a little T chart here, and we'll, so X is the square feet, and then Y is the dollar cost. So if we have 0 square feet, it's going to cost you $2,000 just to come out. And then if you have, 1 square foot, it's going to cost you $2,010. And then, 10 square feet, 10 times 10 square feet is 100 plus the 2,100 plus the 2,000 for coming out. It looks like this. So maybe this helps you see the problem better. So this is our B, right? 2,000 is our B, our starting point. And our M is 10. We could see that here because we have that per thing going on, right? The per tells you our rate. Per, that's usually our rate. And so that's our slope. But you could also see it here. Delta y is 10 and our delta x is 1. So 10 over 1 equals 10. So you can see it either way. So what is our equation? Our equation then is y equals 10x plus 2,000. And y is our cost. And x is the square feet that you're installing. And so that's Billy Bob's equation. Sorry, that's AAA's equation. Now let's look at Billy Bob. Billy Bob, you can do the exact same picture, the exact same t-chart, the exact same math, and you can find out that y is equal to 15x plus 500. I'm not going to redo all this same math because it's the exact same with just different numbers. So now we have to figure out, when do they cost the same? Well, let's use substitution again. So we get 10x plus 2,000, right? If y is equal to 10x plus 2,000 and y is equal to 15x plus 500, we can just set those y's equal to each other and solve. So now we're going to subtract 10x from both sides, and we get 2,000 equals 5x plus 500. Subtract 500 from both sides, and we get 1,500 equals 5x. So x is equal to 300. 300 what? X equals 300 square feet. And that's when they cost the same, because that's we set them equal to each other, right? So how much do they charge at 300 square feet? Well, they must cost the same, but let's just figure this out. Y equals, we're going to substitute our x back in. And this is what AAA charges for 300 square foot floors. And that's 3,000 plus 2,000, and that equals $5,000. They charge $5,000 for installing a 300 square foot floor. Now we know Billy Bob's got to charge the same because we just solved these simultaneous equations, but let's just verify that for fun. Let's just verify that, yes, indeed, Billy Bob will charge. And this is so cool how this works out. Watch. Y equals 1,500 times 300 plus 500. Well, that's 4,500 plus 500. And so that's 5,000. Totally cool that that works out. It has to, because math is perfect. So let's see. Let's see, for floors smaller than 300, who gives you the better deal? Well, let's try a really tiny floor of like 1 square foot. Well, 1 square foot, Billy Bob would only charge you 500 plus 15. So 1 square foot would be 515. And over here, 1 square foot costs, we already figured this out, costs 2,010. So AAA, so the idea, and then for bigger floors, AAA is the better deal, because after we get to that 300 square feet, that extra square foot, when you go to 301, it's only going to cost an extra $10, whereas Billy Bob's going to charge you $15. So so the idea is that for smaller than 300 square feet, we want Billy Bob. For 300 square feet, doesn't matter. They charge the same. But for larger, we want AAA, because they're going to be the bigger deal. And you can verify that for yourself. Why don't you try plugging in 500 square feet to both equations, and I think you'll see that AAA is going to be the better deal. They're going to charge you $7,000 for 500 square feet. And Billy Bob is going to charge you $8,000 for 500 square feet. Okay, let's lay down our happy cats. Everywhere we put a box, we just happy catted the heck out of this thing. This was a great problem. You're going to see one like this on the homework. And what I want you to do now is just hang back, congratulate yourself, give yourself a nice hand because you killed it. And go USA, go you, you're rocket. And we are getting through this 8 and 5, just a few more lessons, and we'll be on 8 and 6 before you know it. Happy cat, happy life, happy math.